Hi there, welcome back to another video. Now in this little mini series we're going to take a look at how you go about proving the so-called circle theorems. Now these theorems are really powerful, and if you know them you should be able to solve any GCSE circle problem. But as is usual with my videos, I want us to understand the deeper meaning behind them and why these theorems are true no matter what. So what we're going to do is actually prove them. And this is grade 8 or 9 stuff, so if you're doing this, you're doing pretty well. Now, firstly, we just need to make sure we're familiar with circle notation. So, the middle point of a circle is called the center. Any line from the center to the edge is called the radius, so that's this line in blue here. Okay, a line from one side of the circle to the other is called the diameter. And in fact, this is 2 times the radius. So I'll just write that. 2r. A line from one side to another that doesn't go through the center is called a chord. So that's its orange line here. Now, when we have a chord, we can see we split a circle into 2 parts. We've got this part here and the rest. Now, the part of the circle made by joining this chord is called a segment. So this bit in purple is called a segment. Right, and similarly, if we attach 2 radii, so lines from the center to the edge, we again split the circle into 2 parts. We've got this blue shaded bit here and the rest of the circle. And this blue shaded part is called a sector. Finally, the distance round the outside of the circle is called the circumference. And there's a nice formula for the circumference. It's 2 times r times pi. And because 2r is d, diameter, this is just pi times d. So this equals the circumference. Right, so assuming you're happy with all this notation, we will move on and prove the first circle theorem. Right, so this is the first circle theorem, and what it says is the angle formed at the center is twice the angle formed at the circumference. Now, taking a look at this diagram, this means that this angle here is 2 times as big as this angle here. Now you might see a lot of fancy terms with this theorem, like the angle subtended and all these fancy words. They're just trying to throw you off. This theorem basically means that this angle here is nothing more than 2 times this angle here. And we'll go ahead and prove it now. Okay, so let's go ahead and prove this. Now remember, we're trying to prove that this angle here is twice as big as this angle. So let's call this one 2 times x and this one x. Okay, so this is what we're trying to prove. Right, so starting off, we can see that OA and OC are radius, or radii. Radii? And this is really useful. Now we're going to draw a straight line from O to B, like so, and this is also a radii. So it's also a radius. And what has this done? Well, now we can see that this line and this line are the same, and also O to B and O to C. So what we've actually created is 2 isosceles triangles, meaning that this angle here and this angle here are the same. Let's call them x. And this angle here and this angle here are also the same. Let's call these y. So we've created 2 isosceles triangles, AOB and BOC. How does this help us? Well, we know that angles in a triangle add to 180, which means we can work out these 2 angles. So let's write that down. Right, so this angle here, so I'll just point to it, is nothing more than, well, if we know that x plus that angle is 180, means that this angle is 180 minus 2x. And similarly, this angle here is going to be 180 take away 2y, because if we add up the 3 angles, we get back to 180. Right, the angle we are now interested in is this one here. And we can work this out because we know that angles around a point add to 360. So this tells us that our missing angle now is 360 take away 180 minus 2x and plus 180 minus 2y. Okay, so we're just taking off the angles we know from 360, and so we're left with, well, 360 take away 360, we are left with 2x plus 2y. So this angle here is 2x plus 2y, and this angle up the top is x plus y. So we're actually done, because so the angle at circumference is x plus y, the angle at the centre 2x plus 2y, and this is the same as 2 lots of x plus y. So we are done. We've proved that the angle at the centre is twice the angle at the circumference. Hope you enjoyed. Stay tuned for the next one. Bye bye.